David Arnold, and this is my interactive local dashboard project. For this project, I created Brew, which is an interactive dashboard built with Python and Streamlit. The dashboard analyzes transaction level sales data for a coffee company with multiple store locations and menu items. The goal was to create a dashboard that provides a useful business insight while also considers usability, accessibility, data updates, and performance. So I'll start briefly here by showing the Python code used to build the application. At the top here, I imported the main libraries used throughout the project. Pandas is used for loading and manipulating the sales data, and Streamlit builds the interactive dashboard, and Plotly and Matplotlib are used for the visualizations. The sales data comes from a local CSV file. Created a function that uses pandas to read that file and convert the transaction date and time into a format Python can work with. So moving on to Streamlit's cache data feature on this function, I use right over here. Instead of reading the entire CSV again every time a user interacts with the dashboard, Streamlit can reuse the previously loaded data. And then moving on to the sidebar filter code. This section creates the dashboard filters, where users can filter the dataset based on the store's location, product category, or individual product. There. So these selections create a filtered version of the dataset, and the rest of the dashboard responds to the selections. There are additional sections of code that calculate the metrics and build of each visualization, which I can demonstrate through the actual dashboard. So moving on to the dashboard. The top of the dashboard, I included 4 KPIs, KPI metrics, that provide a quick overview of the business performance. These are total revenue here, total transactions, average sale, and average number of items purchased. Below these metrics are several visualizations that provide different views of sales performance. So we have the monthly revenue chart, which allows users to identify changes in revenue over time. You can see that you can also look at revenue by store. Downtown Nashville here, this location is the leader out of the 5 locations. And then you can also look at revenue based on the hour of the day or top products by revenue. Look at the revenue by hour of the day, you see sales kind of dip down as the day moves along. Here, the breakfast sandwich is the leader of revenue by product. For product performance, I added an interactive control that allows users to change how products are ranked. For example, I can rank products based on revenue, number of transactions, or total quantity sold. So moving on to the advanced visualizations. This section provides additional ways to explore the distributions and relationships within the dataset. The first visualization is a interactive Plotly histogram. Users can switch between transaction revenue and quantity purchased to explore how each variable is distributed. The next visualization is a box plot created using Matplotlib. This compares transaction revenue across the different product categories and makes it easier to identify differences in median values, spread, and then potential outliers as well. The third one here is an interactive scatter plot created with Plotly. Compares the number of items purchased with transaction revenue. This project therefore uses at least 2 of the visualization libraries, Plotly and Matplotlib, and includes multiple types of distributions and relationships. The dashboard also includes several interactive features that allow users to explore the info in more detail. Sidebar filters allow me to narrow the data set by store location here, product category, or the individual product being sold. So if you'll see here, when I change the selection of the location, the dashboard automatically recalculates the metrics and the visualizations using the filtered data. Plotly also provides hover information. So for example, hovering over a point in the scatter plot provides information about the product, the store, quantity purchased, and transaction revenue without placing all that information directly on the chart. Scatterplot also supports point box and lasso selections, which you can do up here. When transactions are selected, the dashboard generates a new summary showing the number of selected transactions, total revenue, average sale, or revenue by the product. So this allows you to kind of dive deeper, get a deeper insight instead of simply changing the appearance of the graph. For the accessibility, I use clear chart titles, descriptive access labels, and a color safe palette. These choices were intended to make the dashboard understandable for users across all different levels of technical experience. Performance was another important consideration for the project. Measure the time required to load the dataset both without caching and after implementing Streamlit's caching feature. During the testing, the uncached dataset consistently took approximately 1.03 seconds to load. Once the data was cached, subsequent loads took approximately 0.09 to 0.10 seconds. This represents approximately a 90% reduction in load time and helps keep the dashboard responsive when users interact with the different filters and visualizations. There is a trade-off though. Caching data means that changes to the original CSV may not immediately appear because Streamlit is using the previously stored version. So to address this issue, I have a refresh dashboard data button. So when you hit this button, Streamlit clears the existing cache and reruns the application, which allows the most recent version of the source data to be loaded. In addition to the application, I also made a technical report. Documents the major components of the project. I have an introduction here. Report describes the data set, the dashboard design, the visualizations, user interactions, and accessibility. Also the data update process, and performance and caching strategy. Also have a screenshot of the caching strategy there, before and after caching. So overall, this project demonstrated the importance of balancing functionality, usability, accessibility, and performance when designing an interactive dashboard. This Brew metrics allows users to move from a high-level view of business performance into more detailed analysis through the filtering and the interactive visualizations. Thank you so much for reviewing my presentation. Hope you have a great day.